All right, let's talk about modeling, which is another way of talking about word problems. So let's say you have a solution. You have 100 liters of the solution. It's a mixture of acid and water, and 20% of the solution is acid. So how much acid is in this vat? Well, we can simply translate this sentence. 20% written as a decimal is 0.20. Of means times. The solution, we have 100 liters of solution, is the amount of acid. So 20% of 100 is 20, and always include your units. So we have 20 liters of acid, and if it's a mixture of acid and water, well, if 20 liters of it is acid, how much is water? Right, the rest of it, or 80 liters, is water. Let's do another warm-up problem. All right, we have a 200 liter vat, which is a solution of acid and water. If 35% of the solution is acid, how much acid is in the vat? And if I were you, I would hit pause and work it out on your own. All right. So once again, we have 35% of the solution. So 35% written as a decimal, 0.35. Of means multiply, times 200 is the amount of acid. 35% of 200 is 70. Don't forget the units. That means this vat has 70 liters of acid. And then you can easily figure out how much water is in this solution. Since it's only acid and water, that means the rest, 200 minus 70, or 130 liters, is water. All right, I think we're ready for a more challenging problem. All right, how many liters of a 20% acid solution should be mixed with a 40% acid solution if I want 100 liters of a 28% acid solution? And if you're feeling ready, you can go ahead and hit pause and try this one on your own. Otherwise, let's do it together. So whenever you're solving a word problem, the first thing you want to do is name your variables. All right, so I'm looking for the numbers of liters of 20% acid solution. So that's what I'll call X. All right, so I'm going to write it down so I don't forget. X is going to be the number of liters of the 20% acid solution. And then for these mixture problems, I find it helps to draw a picture. Let me do that. All right, I'm mixing a 20% acid solution with a 40% acid solution, and I want to end up with a 28% acid solution. And I already know the quantity, so I'll write that below. I want to end up with 100 liters of the mixture. And I know that this is X liters. Now, how do I figure out what to write here? Let's make a little table. All right, let's just run some numbers and see if we see a pattern. So if there's 10 liters of the 20% solution, how many liters will there be of the 40% solution? If you guessed 90, you guessed correctly. But how did you get 90? That's right, subtract 10 from 100. What if there are 20 liters of the 20% acid solution? How many liters of this will be? Let's write 80 liters. How did you get 80? You just subtracted 20 from 100. What if there are 35 liters of the 20% solution? Well, if you guessed 65 liters, that would be correct. And how do you get 65? We just subtracted 35 from 100. So now we're ready to see if there's a pattern. So if you know the liters of 20% solution, you just subtract that from 100. So if I have X liters of the 20% solution, then I'll have 100 minus X liters of the 40% solution. If we just follow this pattern. That's going to be 100 minus X. Now let's go back to what we talked about in the beginning. How many liters of acid are in this vat? Well, it's going to be 20% of the number of liters. How much acid is in this vat? Well, it's going to be 40% of this number of liters. And that's equal to 28% of 100. And then I would hit pause and work it out on your own. Distributing the 40. You get 40 minus 0.4x. Combine like terms and subtract 40 from both sides. And then divide both sides by negative 0.2. And we get 60. And then always go back. Because remember, you started by naming your variable. So I know what this x represents. That's 60 liters of the 20% solution. And then we can go back here and we know how many liters of the 40% solution. And then whenever you're solving a word problem, just ask yourself, does this make sense? So if you got a negative number, it would start all over, or something that didn't add up to 100, that would be something of concern. All right, let's try another one. All right, this one's a little bit more challenging. And I would hit the pause button and try this one on your own. If you have 100 liters of a 2% acid solution, how much must you pour out and replace with pure acid if you want 100 liters of a 5% acid solution? All right, so the first thing you want to do is name your variable. So we're looking for how much we need to pour out. So that's what X is. It's the amount that is poured out. It's also the amount that we replace with pure acid. So let's draw a picture. So we started out with 100 liters of the 2% acid solution. We're going to pour out X liters. So I'm going to put a minus sign here because we're subtracting that. And then we're going to replace it with pure acid. Well, what percent acid is pure acid? That would be 100%. And how many liters of the pure acid? Well, it's the same amount that we poured out, so that would also be X. And then we're going to end up with 100 liters. So let's write that equation. So 2% of 100, which is 2. I wrote 1x because 100% as a decimal is 1, or you could just write x. Combine like terms. Subtract 2 from both sides. And divide both sides by 0.98. And then go back and check. That's the liters of 2% acid solution that's poured out. You ask yourself, does that sound about right? And it does. All right, let's do another one. All right, the most common type of word problem that you do in algebra is called a rate problem. Some people call it dirt. Distance equals rate times time. I like to write it with the rate first. Now, the one we just did, the percent, is actually a rate problem because a percent is another way of writing a rate. So percent of whole equals part, or miles per hour times hours is equal to miles. That's rate times time equals distance. But there are many other types of rates, like dollars per pound times pounds equals dollars. So when solving a rate problem, first I like to recognize that there's a rate and then write the rate equation and use it to help you organize the information. All right, so first you want to recognize that you're solving a rate problem, and we'll practice that in a minute. You'll write the rate equation like we've done here. Always name your variables early in the problem, and then organize your information. So let's recognize some rates. All right, each box has 16 cookies. This is a rate. What do you think goes in the numerator? All right, so if you guessed cookies per box, you'd be correct. Usually the thing that there's one of goes in the denominator. So 16 cookies per box. And then the rate equation would be cookies per box times the number of boxes is equal to the total number of cookies. Every class has 35 students. What would be the rate? That's correct. Students goes on the numerator. And the rate equation would be students per class times number of classes equals the total number of students. There are 24 hours in a day. What would be the rate? That's hours per day. And then the rate equation would be hours per day times the number of days is equal to the total number of hours. Let's solve a rate problem. All right, you spent a total of $35 on a mixture of cashews and peanuts. Cashews cost $3.50 per pound, and peanuts cost $2.50 per pound. You bought 2 more pounds of the peanuts. How many pounds of each did you buy? This would be a good time to hit the pause button. Try it on your own. All right, before we do anything else, let's name your variable. So we're looking for the pounds of cashews and the pounds of peanuts. Now, the number of pounds of peanuts is being used in this description of the pounds. So let's call X the number of pounds of cashews. Because the pounds of peanuts is 2 more than, we can use that description to write the number of pounds of peanuts. All right, and then you saw these rate words. So we know it's a rate problem, and the rate is dollars per pound. So then you're going to write your rate equation. And if there's more than one rate, it's often helpful to make a chart to organize your information. So I can make the first row our peanuts row, the second row our cashews row, and we can use this for totals if there are any. And if you haven't solved it already, I would hit pause here and fill it out. All right, so I know the dollars per pound for cashews. I'll put that in the dollars per pound column. The dollars per pound for peanuts goes in that column. And then the number of pounds of cashews is X. Number of pounds of peanuts is X plus 2. And I know the total dollars for both is 35. So multiplying 2.5. Don't forget to use parentheses when you're multiplying by an expression containing plus or minus. And it's always helpful to take a moment here. This is our peanut row and the dollar column. So this represents the number of dollars spent on peanuts. This is the dollar column and the cashew row. So this is the number of dollars spent on cashews. So our equation is going to be the number of dollars spent on peanuts plus the number of dollars spent on cashews, and that's the total number of dollars. Distribute. Combine like terms and subtract 5 from both sides. And then always go back. Say, what did I name my variables? Well, 5 is the number of pounds of cashews. And then we use this expression to find the number of peanuts. All right, let's do another. All right, you and your sister live 415 miles apart and drive towards each other. You drive 55 miles per hour and she drives 65 miles per hour. She left 1 hour later. How many hours did each of you drive? If you want to try this on your own, I would hit pause. All right, the first thing you want to do is name your variables. So we're looking for how many hours each of you drove. She left 1 hour later, so we can use this description to find her variable. So let's call X the number of hours you drove. If she left 1 hour later, then she drove less hours. So that would be the number of hours that your sister drove. All right, this is a rate problem, so let's name the rate. And if I were you, I would hit pause here, write the rate equation, make a chart, and try to fill it out on your own. Right, but if you're not ready to do that, maybe you could just start here. So the rate equation is miles per hour times the number of hours equals the total number of miles. You could name the first row you, and the second one your sister, and then a third row for totals if there are any. Now you're driving 55 miles per hour, so that goes in the rate column. She drives 65 miles per hour. And the total number of miles you drove together is 415. You drove X miles. She drove X minus 1 miles. So multiplying across. I always like to stop and take a moment to examine these expressions. So this is in the U row in the miles column. So 55x represents the number of miles that you drove. This is in the sister row in the miles column. So this is the number of miles that your sister drove. This is the total miles that both drove. So the equation is going to be the number of miles you drove plus the number of miles your sister drove is 415. Distribute. Combine like terms. Add 65 to both sides. Divide both sides by 120. And go back. X is the number of hours that you drove. She left 1 hour later. And always go back and check with the original problem and see if that makes sense. All right, let's do another. All right, work problems are another really fun type of word problem. There's multiple correct ways to do this, like most problems. So we'll look at one. All right, it takes Bob 3 hours to clean the whole house. So what part of the house can Bob clean in 1 hour? Well, if it takes 3 hours to clean the whole house, he can clean about a third of it in 1 hour. Let's write that down. All right, it takes Sarah 4 hours to clean an entire house. So what part of the house can she clean in 1 hour? Well, if it takes her 4 hours to clean the entire house, in 1 hour, she can clean a fourth of the house. All right, let's name our variable. We're looking for the number of hours it will take to clean the house working together. So if Bob can clean a third of the house in 1 hour, and Sarah can clean a fourth of the house in 1 hour, then what part of the house can they clean in 1 hour if they're working together? Well, that would be 1 over x. Let me write that down. All right, so 1/3 plus 1/4 is equal to 1 over x. And since we're dividing by x, x cannot be 0. Of course, that makes sense. There's no way they could clean the house in 0 hours. Oops. All right, so we find the least common denominator, which is 12x. Multiply both sides by 12x. Distribute. Remember, you always distribute before simplifying. And reduce. X is the number of hours. Let's make this a decimal so it'll make more sense. I'm going to use the approximately equal since I'm rounding it off. And then ask yourself, does this number make sense? Well, working together, it'll take less than 2 hours. That sounds about right. Let's try another one. All right, it takes 8 hours to fill an empty pool. A leak can empty a full pool in 24 hours. How long will it take to fill the pool with the leak? So if I were you, I'd hit the pause button and try this one on your own. All right, so always remember to name your variable. Let's call x the amount of time required to fill the pool with the leak. So we can fill, what part of the pool can we fill in 1 hour? If it takes 8 hours to fill an empty pool, and that would be 1/8 of the pool. What fraction of the pool can be emptied by the leak in 1 hour? Well, that would be 1 over 24th. Now before, the two parts were working together, but these are working against each other. So we're going to subtract. The part of the pool that can be filled in 1 hour with the leak will be 1 over x. And again, x cannot be equal to 0. Of course, that makes sense. You can't fill a pool in 0 hours. Find the least common denominator, just 24x. Multiply both sides. Make sure you distribute before you simplify. So we get 3x minus x equals 24. 2x equals 24, so x is equal to 12 hours. Does that sound right? Of course, it'll take longer to fill the pool with a leak in it. And that's that.